All right, I want to thank everybody who's joining us in person today and also all of you out there on Zoom. We really appreciate you joining us this evening. We're going to have a very educational and thought-provoking panel this evening on the topic of There Is No Planet B, a call to address climate change. And before I introduce our moderator for this evening, I just want to talk a little bit about the organizations that are bringing you the program this evening. This program is sponsored by the J. Robert Oppenheimer Memorial Committee in partnership with PEAK, the Pajarito Environmental Education Center. And so we're both very happy to be presenting this program this evening. I want to talk a little bit about the organizations. PEAK is a nonprofit that operates the Los Alamos Nature Center, which is where we are today. And PEAK is providing the venue both for the in-person event as well as all the Zoom arrangements. So we are very grateful to them for their assistance. PEAK's mission is to enrich people's lives by strengthening their connection to canyons, mesas, mountains, and skies. And they have wonderful programs for both indoors and out of doors for adults and children of all ages. And obviously the topic this evening is of great interest to PEAK and all its supporters. The Oppenheimer Memorial Committee, our mission is to bring forth the legacy of J. Robert Oppenheimer and his love of lifelong learning and his appreciation of knowledge of the world around us. The Oppenheimer Committee is coming up on our 50th anniversary here in November, so we've been around for quite a long time. The two main activities that the committee takes part in is putting forth a public annual lecture every year, the Oppenheimer Memorial Lecture. And this year we've elected to do a panel instead because we felt with the Zoom medium the panel would be more interesting and engaging for our Zoom viewers. Our other main activity is to award scholarships to area students. And this year we awarded 11 scholarships, 7 to the amazing students from Los Alamos High School, including Filippo Delzano, Karen Eby, William McTeague, Anthony Lestone, Ursula Coe, Ethan Jones, and Logan Black. And then we also each year award scholarships to some of our regional school students. And those include Bella Root and Michaela Mutz from Santa Fe High School this year, Geraldine de los Santos from Capitol High School, and Leah Trujillo from Pewaukee Valley High School, who is here with us this evening. So thank you. So I'm going to now introduce our distinguished moderator. We are lucky to have Dr. William Press with us this evening. Bill started his career as a professor of astronomy and physics at Harvard University and went on to take many important roles, including being a member of President Obama's Council of Advisors on Science and Technology, as well as a deputy director here at Los Alamos National Laboratory. Bill is currently the Leslie Surgener Professor of Computer Science and Integrative Biology at the University of Texas at Austin, and also a senior fellow at Los Alamos National Lab. So thank you very much, and Bill, it's all yours.
Thank you, Wendy, for that kind introduction. I need to say something about COVID precautions that we're doing here. I and all the panelists are fully vaccinated, and here in the Peak Planetarium, we are all 6 feet socially distanced, and the limited capacity audience here is masked and socially distanced. So for the benefit of the remote audience and consistent with local and CDC guidelines, we're going to allow the panelists to remove their masks during the session, during the discussion, to speak, and continuously keep them off because they may want to interject or interrupt each other. That's something that we're encouraging to have a lively discussion tonight. Well, this is an opportune time for this discussion about climate change. As I suspect almost everyone listening knows, the Intergovernmental Panel on Climate Change, the IPCC, this week issued the summary and first volume of its encyclopedic 6th assessment report. And the wording that it uses is dire. The last decade was hotter than any period in the last 125,000 years. This is the first time that the IPCC has felt able to use the word unequivocal about evidence that climate change is human caused. And our panelists, I think, will have a lot to say about both the IPCC report and its findings. We have three very distinguished panelists, and my first task is to introduce them to you. Since tonight is not just about the science, but also in a way about the scientists, I'll give each a very bare bones introduction, and then I've asked each of them to say a couple of words, no more than a couple of minutes, about their backgrounds, how they got interested in science, or just any anecdote that they think would be interesting to the people in the broad audience. Now, our time tonight is so limited that not only here, but later in the discussion, I hope the panelists won't mind my interrupting them to keep us all on schedule. And they know that I was going to say that, so they've agreed. So first, let me introduce France Cordova. France is president of the Science Philanthropy Alliance, and she's a former director of the National Science Foundation. Her original field of research was astrophysics, and from that she went on to become NASA chief scientist and then chancellor at University of California, Riverside. And after that, president of Purdue University. She was the first, and I think to date only, woman president of Purdue. She was nominated for the important position of NSF director by President Obama, confirmed by the Senate, and she served both in the Obama administration and in the Trump administration. So with that brief introduction, France, what else can you tell us about your background?
Well, you said maybe we could say a little bit about how we got interested in science, but I'd like to say a couple of words about how I got interested in New Mexico, because I think this is such a special place. So my first trip to New Mexico was when I was a graduate student at Caltech, and we came out here to launch rockets from White Sands Missile Range because I was a space scientist and astrophysicist. And that was very interesting and great fun, observing the cosmos from White Sands. And then when I was about to finish up at Caltech with my PhD, I was invited here to give a talk by a friend who had been in my group at Caltech and was now on the staff here. And so I came just to see him and see the scenery. And I just fell in love with this place. I just thought it was amazing. And when they turned around, the administrators here, and offered me a job on the staff rather than a postdoc after getting my PhD, I thought, wow, that was great. And no offense, Bill, but Harvard offered me a postdoc, and I turned it down to come here as a staff member, and had a wonderful decade. And the highlight of the decade was actually meeting my spouse, who was a teacher in the high school at Los Alamos, and we met rock climbing and having our 2 children here in New Mexico. So it is a place that naturally we decided to come back to after we were finished with some of our other jobs.
Thanks, very interesting. Our second panelist is Dave Gutzler. He's a professor emeritus at the University of New Mexico, and he is a world-recognized atmospheric scientist. In fact, we were talking about the IPCC report. Dave is a lead author on volume 2 of the IPCC assessment, which will be issued sometime around the end of this year. Dave's PhD was from MIT in meteorology. His research group at UNM focuses on the use of data and models for the causes and impacts, not just of world average climate change, but specifically regional projections, including the American Southwest, something that I think we'll be very interested in tonight. So Dave, what could you add to that?
Well, I've been here for 25 years, but my academic training and research before we came here was in weather and climate variability, which I simply stumbled into as a grad student without having any, simply because it sounded interesting. And when my wife and I moved here to UNM, they were hiring her, and I was the spousal baggage that needed to be accommodated for them to hire my wife. I had no background in climate change or human-caused climate change, which at the time was kind of walled off from natural climate variability and as a scientific research endeavor. So my introduction to climate change came simply because UNM asked me to teach a class about something that I was too embarrassed to tell them I didn't know much about. So I guess the moral of all that is simply to keep an open mind as we move forward in our careers, because you never know what opportunities will come along and what new research topics to explore might fall into your lap.
Thanks. Thanks. Very interesting. Our third panelist is Alex Jonko. She leads the Los Alamos National Laboratory effort in Applied Terrestrial Energy and Atmospheric Modeling Team. And if you think about it, the acronym is A-Team. Her specialty is physics-based atmospheric modeling, especially on regional impacts such as wildfires, something of interest to us here. She's been at LAML since 2014, and before that she was a postdoc at NCAR in Boulder, Colorado. Alex, what can you add to that?
I will add, I am the team leader of the A-Team, and my husband and I also own a GMC Safari. None of you got that joke, okay? And I started out in climate much like Dave through meteorology. My undergraduate degree was in meteorology from Germany, and I got interested in that when I was in high school. So I had two big motivators to pursue meteorology in college. One was that I grew up in an area where you could really see the sky. It was rural Germany, tiny little village, big sky, and you could observe the big weather. And we're talking sort of German big weather here. So some light convection and a scattered thunderstorm. We don't have tornadoes, hurricanes, or any of the fascinating weather you can study here, but still I was hooked. And then I talked about this to my physics teacher, and he said to me, well, Alexandra, there's a lot of math and physics involved in that, and neither of those are your strong suits. So that, of course, made me want to go there even more. And I ended up getting my bachelor's, master's, and PhD in that area. So, you know, started out just wanting to prove my teacher wrong, but now I really enjoy it and still like doing atmospheric science.
That's great. I think if a teacher said that to a female student today, we would string him or even her up. Anyway, all science begins with data, and all science is based on evidence. Now, we could spend hours here reviewing the accumulation of evidence that climate is changing, and that much of that change is human caused. The focus of our panel is going to be in slightly different areas. But to start off with this idea of data and evidence, I wanted to ask France to tell us about some interesting experiences that she had as director of NSF in making the evidence for climate change visible, in fact, tangible to one very important constituency, and that is members of Congress. France?
Right. So, Congress funds the science agencies, and so it's very important to get their support. And of course, they are elected by the people, so indirectly, all of the support for the science that we fund in the federal government is from the public. It's very, very important, the interactions with Congress. And we realize, and during the early part of my tenure as director of NSF, it was led by the Republican side, the House led, Republicans led the House. And so they were a little bit tough to convince on climate variability, climate change. And so we thought, well, we'll invite them to Antarctica, because NSF runs the US's 3 stations in Antarctica, including the only station at the South Pole. And so we took 10 of them on what's called a CODEL, a congressional delegation to Antarctica. And there it was just such a wonderful opportunity to show them firsthand what was going on. And they talked, as we went to the different field stations, sites, we flew from McMurdo Station on the coast to the South Pole. We would meet our young scientists everywhere, and they were just so full of enthusiasm about the research they were doing. And I think it was very, very compelling. And the congressman asked great questions, and they felt very relaxed because nobody was trying to push climate change on them. We were just letting them see what it was like. And we did the same thing with a group of congressmen in Alaska, where the permafrost was really melting, and they got to see that firsthand, and how the communities, they met with the indigenous people there, and heard in their voice how things had changed so much with the hunting and getting ocean animals and that didn't have the sea ice to crawl up on anymore, and so on. And then finally we did a trip to Greenland as well, and Greenland with the glaciers just melting back and just so much change and variability. So I think, Bill, that was a really good way for them to actually see the evidence and experience firsthand and get a chance to ask questions, because that's really what communication is all about, is both camps getting to ask questions and listen to each other.
Thanks. Dave or Alex, do you want to say anything about, if you meet someone who's a bit skeptical, what do you point to in terms of data, evidence, and so on?
Well, increasingly, it's easy in this part of the world to find features of the climate system that people actually see and interact with and notice. And so it's an easier sell than some other places. Somebody who goes fishing knows that snowmelt runoff is happening in most of the rivers in New Mexico 2 weeks earlier than it was just a couple of decades ago. I have pictures of my kids going to the balloon fiesta in Albuquerque in October, and they're all bundled up. Well, you don't have to bundle up to go to the balloon fiesta at dawn, typically, down in Albuquerque anymore. So the rate of change of the climate here is rapid and noticeable beyond just pointing to a graph that's headed up to a lot of people. So I think anything we can do to help point people in the direction of climate change that they can actually sense personally helps with the personal understanding that's critical for public support for doing something about this.
Mm-hmm. Alex, you've made your career in the United States, but you're natively a European. What do you think is the difference between European and American attitudes towards the evidence for climate change?
Loaded question, Bill. I've done most of my education and worked as a scientist in the US. And so I have mostly the American perspective, but I think, I don't know, I don't want to say anything too inflammatory.
To your newly adopted, not so newly, to your adopted country.
Newly adopted. I've been a citizen for a year now. So
congratulations.
Thanks.
Okay, well, Alex isn't going to take that fastball. A lot of tonight's discussion is going to be around modeling, which means computer modeling. Now, there's a set of very wonky people in the world who actually develop the intricacies, the computer coding of these models. And then there's a larger, very important community that we have represented here tonight by Dave and by Alex, who are the users of these models, the interpreters of these models, and the people who try to draw conclusions from what the models are telling. Now, in some of our discussion before this panel, Dave pointed out to me the important distinction between projection and attribution as uses of models. So I wonder if he could explain the difference. And I think it's going to turn out that Dave does relatively more projection and Alex does relatively more attribution. But if they want to make a liar out of me on that, they're welcome to. Dave, do you want to kick that off?
Sure. Climate models are now sufficiently developed that we can use them for all kinds of purposes. As you pointed out, Bill, the most common use that maybe people are familiar with is to use models as tools for looking at the future. So a climate model is really a souped up version of a weather forecast model, the kind that was developed first after World War II. And we use climate models to make projections of future climate by forcing the model using some guess for how greenhouse gas concentrations might change in the future. And since we don't know how those greenhouse gases will change, in large part because it depends on what people decide to do about emissions, we can use models and run them over and over again with different guesses for how rapidly greenhouse gas emissions will increase and see how the models respond. But that's not the only use for models. We also use models to play what-if games and to take a look and help us understand what's happened in the past and interpret the data that we've gathered, because we can use models to run controlled experiments on the climate system. You should be thankful that we're not doing controlled experiments on the real climate system. But with a model, we can mess up the climate or change anything we want safely. And we can run the models, for example, by not having greenhouse gas concentrations change at all over the past century, and then use the models to tell us what the models think the difference in climate would be if people hadn't been emitting greenhouse gases over the past 150, 250 years. And that process is called attribution, because it allows us to simulate a hypothetical baseline climate and see how different the actual climate really is. That's based on actual changes in greenhouse gas emissions. And more recently, in the report that was just released this week, there's an extended discussion of how, using models, we can estimate how the likelihood of extreme weather has probably changed, and whether various extreme weather events like Hurricane Harvey inundating Houston a couple of years ago, how much likelier that is now in a changed climate compared to the climate that we think would exist if people hadn't been affecting it by increasing greenhouse gases. So we use the models for that. And then finally, and then I'll quit, we shouldn't forget that as scientists, we use models just to understand how systems work. So beyond trying to replicate reality, we use all kinds of climate models just to play games and run all kinds of simplified experiments, again, not on the real system, to try to understand how various perturbations affect the system. And that's, I think, a lot of what Alex and the A team does, is to use models to assess the effects of.
Well, let's get Alex to tell about what she and her team do in using models at the lab at Los Alamos.
Sure, yeah. So for the last couple of years, a lot of people on my team and myself have been working on wildfire modeling. And so we're looking at attribution of wildfire trends with a new project across the state of California, where we're running the vegetation model coupled out of a global climate model. And we're turning processes like climate change and then changes in vegetation due to management, as well as the distribution of humans, where people are moving to and how that impacts where ignitions are happening, to see if the trends that we're now seeing with wildfires, which you've all seen in the news in the last couple of years have been pretty devastating, are due primarily to climate, to the fire suppression efforts over the past 100 years that we've been implementing, or due to the fact that there's more humans living near forests where they can accidentally start wildfire? And of course, the answer is going to be a little bit of everything. But with modeling, we can disentangle what are the proportions. And we're hoping that this will get us answers about what are the most likely mitigation strategies to be effective. If it is 90% climate change, say, then we know we really have to do climate mitigation and work on larger scales across the globe to address this problem. But if it is really mostly due to our management approach, that's a much more localized problem that we can address on the ground. There's also a lot of hydrological research going on. And so a project that I'd like to highlight is looking at the Pajarito Plateau here locally and how the snowpack versus precipitation is expected to change in the future and how that's going to impact stream flow and also the water that vegetation has available. And so we're also using models to sort of parse out when more water is going to be falling as rain in the summertime, there's going to be less infiltration, more runoff, and that means less water availability for plants and more aridity. So those are just a couple examples I'll mention.
Interesting. We're starting to get some questions from our remote audience, and most of those we'll save for the end. But I see that Ed Birnbaum is asking a question that fits right in here. He asks, what do the models tell us if the Gulf Stream shuts down, and how likely is that?
I will take a stab.
Give it a shot.
And let me say right up front, I'm not, my answer is going to be based on the previous IPCC assessment because I haven't actually gone through the new one to see what they have to say about ocean circulations. But there is some thought that climate change could affect the circulation in the Atlantic Ocean, which is where deep water forms for the global oceans. The North and South Atlantic Oceans are one of the few places where the ocean water on the top can become denser than the water below and sink. And so if we change the density of the ocean water in the Atlantic, we could affect that process and effectively shut down what's called the ocean conveyor belt. And one way to do that is to warm up the top of the ocean and dump more fresh water in the form of precipitation onto the North Atlantic. And those are two projections from climate models. So there's been a lot of interest for the past couple of decades since a guy named Wally Broker first proposed this to see if projected climate change over the next century or two might actually warm up and freshen the North Atlantic sufficiently to inhibit the formation of deep water and let that surface water just pile up. Now, how likely is that? As of a few years ago, the answer was not very likely in our lifetimes. But moving out in time, a century or two, the risk of that happening goes up. And if that happened, it would be a major perturbation on global climate. A measurement campaign has been initiated because this was basically a conceptual and modeling idea to actually try to measure this oceanic conveyor belt in the Atlantic. And those measurements have indicated that the Atlantic conveyor belt is actually slowing down somewhat, but it hasn't stopped. And it doesn't seem likely, unless things have changed dramatically in the newest generation of models, that is an imminent risk, but it is definitely a risk sort of in the far future.
Thanks. Back on wildfires, France, I'm remembering that earlier you mentioned that you were following political events on Capitol Hill that would relate to congressional action on wildfire. Am I remembering that right?
Yes, I try to follow a lot of what's happening with trends because, and the reason is because I lead the Science Philanthropy Alliance, are the foundations that are members of that want to know where their investments can have the most impact. And climate research is one thing of great interest to investors, not only in the government, but also in the philanthropic world. And so we really need to keep an eye on what are the trends in Congress. So the House Science Committee has been having a lot of conversation recently about fire resilience and mitigation, and wants to introduce a bill very soon, but has given a lot of inclinations of what it's going to look like to both do better satellite monitoring. I know NOAA has a number of satellites that are supposed to go up around the year 2030 and beyond, but they think that's too far in the future and we should be doing something sooner. And also the resolution, the spatial resolution of those satellites is not very good. So they want to have better spatial resolution. So that's one effort that they want to put some more money into. And also intergovernmental coordination. I think that's the bane of any big country with a lot of fabulous distributed organizations, is that a lot of times they don't work together as well as they could. And certainly in the world that we're talking about, and fire is just one example, but just take any example to do with the oceans or the atmosphere, land, Antarctica, the Arctic. There are so many different organizations, and getting them all to move coherently would be a huge plus, and to do the actions, like the actions that will be recommended by the IPCC eventually next year, is just essential that the government agencies coordinate. So Zoe Lofgren from California is leading the effort on the House Science Committee to introduce a bill to specifically address wildfire science and technology with these different components.
Interesting. A little bit off our main topic, but I know you're an expert on it, and now you've served both in government and now you're serving philanthropy. What is going to be the balance there, not just on climate science, but on many other sciences, between what's the best use of scarce philanthropic dollars versus what's the best use of scarce federal government dollars?
Well, that's a huge question, and it's changing in real time. There are bills in Congress right now, the big reconciliation bill that I think you've all read about, that's kind of a partner to the infrastructure bill. Only the reconciliation bill is $3 trillion and the other bill, infrastructure, is $1 trillion. So there's a lot of discussion over giving more money to the science agencies. And I know NSF in particular has something like $30 billion over 3 years in the reconciliation bill at stake. But to invest a lot more in science and technology, because it so informs things like climate change and so many other of the global challenges. And I think Congress is very interested in the US maintaining its global leadership. And so there is an active movement to plus up the budgets of the science agencies, which will be great for all the scientists that are doing, modeling and assessment and just trying to understand, expand our knowledge. Now, the philanthropic world feels very similarly that they want to invest in science because they believe that it's key to addressing our challenges. They are very different in their response time, in how flexible they can be. They don't answer to Congress. They answer sometimes to their founder or to their boards. They can move more quickly to do demonstration projects, pilot projects, which can then be, there are many examples of where philanthropy has stepped in to fund something in science that then has developed a proof of concept. So the government can then come in and is more convinced, because they're less risk-taking than philanthropy can be. The government comes in and then funds it at a bigger level. I will say, just for one statistic, that if you count all the dollars that go to universities and research centers from philanthropy, and you count in philanthropy the endowment funds of university, which after all were given because of philanthropists, that number is 44%. So it's not small amount of money that philanthropy has historically and is presently giving to basic scientific research.
Interesting. And now you've touched on another interesting piece in the inhomogeneity in the way American science is supported and done, and that is that we support science at research universities such as UNM, of whom Dave is an example, and we support it at national labs where I know, France, you've been in earlier in your career and I've been in mine. Alex is now. Alex, I'll throw another unexpected question at you. What attracted you to come and make your career at a U.S. national lab as opposed to looking for an academic position, or maybe not as opposed to, but what's your thinking on those different roles in science?
Yeah, I mean, part of it was definitely the beauty of New Mexico, like France mentioned. When I drove up here for my job interview, I was just blown away and I thought I really wanted to come live here. But then I also realized working at the National Lab, we're working on bigger collaborative projects, and we're also switching a lot between different projects we work on. So I think I've had the experience, or the opportunity rather, to pick up a lot of new skills and delve into new topics that I might not have been able to pursue were I at a university. I think at the university, it's more individual PIs collaborating with other PIs, obviously, but pursuing smaller projects, versus here we are maybe not PI of most of the research we do, but we're contributing to a lot of different projects and we're able to learn a lot of different things. And so I really like that breadth. I like the opportunity to continuously be learning and, to jump on things where I don't really have experience and being given the opportunity to pick up something new. That's super exciting.
Yeah, I personally think it's a great strength of U.S. science that we support U.S. science both in university environments and in national labs and other research centers. But I'm only the moderator. I'm not supposed to have opinions on these things. I want to gradually tilt us towards questions of public policy. And we've been talking about regional trends such as wildfire. And Alex, you mentioned that the public policies would be very different depending on how much is due to human-caused climate change, how much is due to forest and wildlands management, and so on. Dave, what are the implications of your work to policy? And first, I'm going to ask at the state and regional level.
Well, one of the most pronounced effects of climate change here in New Mexico is on our water resources. I have focused on that a fair amount just because it seemed like an interesting question and because it does have policy relevance. So we have tried within our research group to improve seasonal predictions of stream flow and summer monsoon precipitation. And as we have proceeded with that, and as the effects of climate change have become more apparent, I'm now helping to edit an analysis for the New Mexico Interstate Stream Commission, which is essentially translating climate change science into a 50-year outlook on the effects of climate change on water resources for the state, which is a big issue here, and one where almost all the trends associated with climate change are in the wrong direction from the perspective of our water resources. So less snowpack, smaller stream flows, higher evaporation rates as temperature rises, more aridity, as Alex mentioned already, et cetera. So we're trying to document and quantify that as best we can for state policymakers.
Can I add something to that?
Please do.
I had the opportunity to visit Arizona State University a couple of years ago and seen what they're doing. And of course, Arizona has similar drought issues to New Mexico. And they had this remarkable center called, had a big name in front of it, but it was a decision center where they would, they had a big room like this with computer screens around the entire inside of the room. And the representatives, it's almost like a Congress, were from state and local government, universities, just every constituency, Native American constituency, the people that ran the power plant, the nuclear power plant that's there on the California-Arizona border. Everyone was there, and they were all doing modeling and simulations in real time. I just thought it was fascinating to address these kind of policy issues of what happens if the nuclear plant decides that they're going to use deep underground water instead of the water coming through, you know, off the Colorado River or whatever. And if they change different variables in how they did their water usage, each of these constituents, what happens? What does that do for everybody else? And I thought, what an interesting thing to get all these citizens and different stakeholders together, all with very sophisticated tools, because they had the computational tools to do the modeling and the simulations in real time. So that's just an example of, you know, taking the science that we know and creating an environment where people can be sharing their perspectives and inputting and changing variables.
I think that's a big future direction for our modeling efforts, is to develop systems dynamics models of that sort with very nice user interfaces. So you don't need to spend 6 months learning how to program a model and then bring stakeholders together and let them play. I think that's a great technique, both for getting people who ought to understand the science to really engage with it, and to help people understand what their options are and how sometimes counterintuitive results come up when a knob gets turned over here and somebody else does something over there, and it just is the way we need to move forward to get science into the hands of policymakers who need to understand and use it.
Thanks. A remote viewer is asking a question about the Lanel fire model. Is that in your group, Alex, or is that somewhere else?
That is in our group.
So the specific question is, how is that being used? And I guess in the context of what we're talking about now, is it being used by policymakers in a useful way?
So we have two different models, I should say. We have our sort of high performance computing model, which is all full computational fluid dynamics and resolves the motion of the atmosphere and interaction between vegetation, topography, atmosphere, and fire. And then we also have recently developed a fast running tool, which can be used on a laptop. It doesn't require high performance computing resources. And so that model was developed more with that sort of application in mind, to be able to put it in the hands of decision makers. I don't know to what extent policymakers have access to it, but I know we're working with land managers and people, you know, implementing prescribed fire strategies, and it's to train fire managers and land managers basically to be able to expose them to more conditions than what they can see in the field, so that they can gain experience through this modeling tool, in addition to what they also see when they go out and, you know, put fire on the ground, so that they can basically do so more safely. And we started doing that work with our high performance model. So we ran only a couple simulations and, you know, basically just compiled a report. But now with this fast running tool, I think we can do a lot more in terms of almost making it like a computer game to train people to understand the dynamics of wildfire, or prescribed fire for that matter, without having to
sounds like a very
observe it.
grim computer game, but a useful one.
Well, I want to say prescribed fire is a very important tool that we have for actually mitigating more catastrophic wildfires. And, you know, a big part of the reason why we're seeing more severe fires now is that we have been putting out too many fires over the last 100 years. So the use of prescribed fire definitely needs to be increasing a lot across the United States for us to be able to mitigate this problem.
We talked a little bit about science funding and science, the institutions of research. We haven't yet touched on what areas of science relating to climate change. Are there particular needs for more research?
I'll just give one example. So I like to give talks about Antarctica, and Pete knows that I actually gave a talk to the Los Alamos Mountaineers back in January about my various trips to Antarctica. And in studying the problems there, I came across a remarkable article which appeared in One Earth magazine in September of 2019, so not very long ago, by Kennicott et al. About 30 scientists got together and they did a horizon scan, which means over a 5-year time scale. They set at the beginning of the 5 years, what were the big questions that they needed more knowledge, more research about to do with Antarctica? Everything from the astrophysics that's being done at the pole, to the atmosphere, to the oceans, to under the ice, to calving and shelving, and glacier melting, and about 6 different really big problems. And then they studied all the research that was being done on those problems over 5 years, and then they came out with this horizon, what they call a horizon scan. And it was just really, really interesting to me as a funder of scientific research, that although we know a whole lot of things and a lot of research is being done, there is so much more that we don't know. And they point out in very specific ways for these 6 different areas with great modeling, what it is that we still don't know. And incredibly important, Antarctica is big, and it's housing a lot of ice, and bad things can happen to the whole planet if it happens to Antarctica, and it is changing terrifically. So I just thought that was a really, really good illustration, that article, of what were some major areas of research, what was being done to attack them. And their conclusion was that there's still just so much more that we don't know. And I think that's where the investors, whether it's the federal government, universities, of course, that get the grant money, the foundations that also fund them, want to know what are the things that are still the big questions that we don't know. And there are many. Maybe you guys have some specific examples.
Dave, do you want to, well, either Dave or Alex, what are some specific, if you had France's former job as NSF director, where would you be pressing your associate directors to put more funds relating to climate? NOAA is also, of course, another.
Well, here in the West, and I suppose I'm a bit biased here because this is related to what we've been groping around trying to understand. Water issues are so critical across the West, as this ongoing drought has demonstrated, that there's a lot we can do to improve the way we try to quantify and understand the regional hydrologic system here. So as temperatures rise, which they're doing rapidly and likely to continue to do, we'll have less snow, and it will be critically important for water management for us to try to have a better understanding of how precipitation in the form of rain and snow accumulates, right? When in the middle of winter, we cannot tell you how much snow is in the mountains. We don't know how to measure that very well, because when you think about it, how would you do that? We have isolated little point measurements, but there's these big mountains with no weather stations and no measurements sitting around, and it's difficult. But we're learning how to do it to measure that remotely. We don't, our understanding of how the snow turns into stream flow, some of it infiltrates, some of it supplies vegetation, some of it falls, gathers in the stream channel and runs downhill. How to quantify all that, we're still in a rudimentary stage of doing that. And then there's the whole question of how to tie those processes to the large scale climate changes that our climate models actually simulate. So at present, we do all that in kind of a empirically derived, not based on first principles sort of way. And we can come up with useful guidance, but it's far from the sort of quantitative, rigorous modeling guidance that we would like to have. And that's both a fascinating science problem, how to do that, and it's one that has big consequences for society across Western North America.
So Alex, I'm guessing we have enough lab insiders in our audience and in the room that I can phrase the question to you this way. If the lab's LDRD budget was doubled, what proposal would you put in?
So Dave's answer made me think about, and this is something I think about in my research world a lot too, integration across scales. So, there are a couple processes, and I think wildfires as well as clouds are two large sources of uncertainty where really we are looking at very fine scale processes that we are still struggling to understand. But then we're also using these global models to represent them in a way and to make inferences about how they're going to impact global climate in the future. So, with clouds, it's kind of the microphysics where we still have assumptions that we really need to research. We don't fully understand all the microprocesses that are happening that generate different types of clouds, that generate rain, and the climate models do still not great in how they simulate those processes. And the same is true for wildfires. There's a lot of very tiny things that impact how wildfires spread that we just cannot put into a climate model. But we need to be thinking about what we represent in climate models and how we can improve that representation based on all those minuscule parts that do play an important role in determining the large scale. So I think that's where we still have a long way to go.
I'm really glad that Alex brought that up because I was worried about an article that appeared in Science magazine at the end of July about that in the IPCC documents that were coming out, that the models that were predicting the future warming were just way implausibly too hot. Okay.
Right.
And this was kind of an embarrassment to some because there's so much, as David was, informing us earlier, there's so much great content in what's already come out and in the future documents. But the models that project what's happening in the future have these weaknesses, and they specifically mentioned about clouds that you just mentioned and fires and all. And so it gives me comfort to think that the scientists are understanding what's wrong with the models, right? Because if you tell the public something that is, that is the sky is falling like tomorrow instead of 100 years from now. I mean, they can get very upset about that, and the models are kind of getting a little bit carried away. So anyway, it's good to have your your knowledge about what's maybe not making the models as good as they can be.
Thanks. I'd like to move us on to the final topic tonight, and then we'll get to some of the questions that have come in. And the final topic is public engagement and communication. What can we do? What should we do? What can the people who are listening in remotely do if they feel strongly about this issue? I bet all panelists have something to say about that, but let's see, France, I know you've thought deeply about this. Can I get you to kick off?
Well, 2 weeks ago, there was a 2-day conference on this this very subject, on the public communication of science, that was sponsored by one of the foundations, the Kavli Foundation, and the Department of Energy, the Office of Science. So it was a public-private partnership. And there were over 2,000 people attending this conference on Zoom. So that I just thought the management feat, I mean, peak, you know, think about that, managing 2,000 people. But they did a brilliant job, lots of breakout rooms and lots of great discussion. And one of the conclusions was that what scientists get really joyous, their excitement comes with making a new discovery. It's full of joy. What the difference is that what the public likes to see, the emotion that they are seeking is hope. They want to know what in this scientific inquiry gives them hope about their lives now and the future and for their children and everything. And there's a distinction between those two emotions, between joy and hope, and how to marry them, to put them together. And there was just a lot of discussion about, you know, it all comes down to that magic word of listening, and that true engagement depends on, you know, being quiet and letting the other side talk, and listening to what their questions are, and making sure there's a lot of questions out there. And there were many examples of how to handle that kind of thing. So I thought, and there'll be results that are published from that, but it was just, I think almost 2,000 people actually got to say something and interact, and they were from all the different worlds of public affairs and communication, but the science world too. And the one other thing I want to add is there's, in the article I referred to, the Kennicott et al. Article, there's one of their 6 big questions for science for Antarctica is about engaging diverse audiences. And they have this quote, which I just kind of put on my desktop, and I always read because it just reminds me of what our responsibility is as citizens. They said, and I'll just read a couple of little pieces of it, but they said public engagement with science is changing. And we all know that there's much more awareness that we should be interacting with the public. And it's really, active engagement is based on establishing a trusted two-way communication. And progress really depends on how fast trust is moving along. And then they conclude with this, I think, amazing sentence that research is increasing understanding of the linkages between knowledge and sentiment and action in science as well as government, putting those 3 things together. And I think that's where our sights are being turned to now, thinking about that deeply.
Yeah. Dave, the IPCC is a very important means of communication with the public and with decision makers. Can you say a few words about your views on, is it effective? Can it be more effective?
I wish it were more effective. The IPCC is very successful at engaging the international media, that's for sure, where there have been front page stories in all the major newspapers. I'm less convinced that the IPCC is successful at reaching the public, other than through the mediation by the media, if that makes sense. That still happens a lot from individual scientists. And so to the extent that the IPCC is successful at engaging individual members of the public, I think a lot of that is done just through individual scientists interacting with school teachers who interact with kids and interacting with the public themselves, which we don't do enough of. And I don't think institutions, certainly like my university and probably like Los Alamos National Lab, I don't think institutions tend to give scientists enough credit and enough motivation to put a lot of time and effort into interacting with the public constructively. And I wish we as scientists and our employers would help us do that more and better.
Thanks. Let's see, Alex, you had a 1 in 3 chance of being the youngest expert on the panel, and congratulations, you win. So let me put you on the spot. France has called for a message of joy and hope, if possible, but more seriously, what would you say to the younger members of our audience about their responsibilities and what they can do looking forward?
Yeah, I would say call your Congress people. I'm, like I said earlier, I've been a US citizen for only 1 year and I haven't been doing great at that. But I think over the years I've learned that I really don't like the message of individual responsibility. I think the government and industry really can do a lot more. And so what we can do to affect change is basically to lobby those people that have outsized power in this situation. I also live my values of believing that climate change is a serious issue and doing things that I can at home, like riding my bike and recycling. But I think much more important than that, all of those little actions combined is really just calling up your congressmen and women and making it known that this is important and that they have to do something about it. And this is me representing my own views and not the laboratories.
I think we understand that. I'll just share something that I once learned from a member of Congress who was very pro-science, who said that the best way that young people can influence what Congress does is show up at campaign rallies every 2 years when your member of Congress is running for office, as they do every 2 years, because that's the time where if there's 5 or 10 students sitting in the front row and they all are wearing t-shirts that say do something about climate or whatever the important issue is, that's when you can really get some attention.
Yeah, that's a good point. And I didn't realize this before I moved to Los Alamos, but for you in the audience who live here, we get the opportunity every election cycle to see every big name come through campaigning. So it's a great town to live in to be able to have a little influence to make our voices heard.
Bill, could I add that I think it's especially important for younger people to make their views known about the climate change issue, because one of the major inequities in terms of enacting policy about climate change is that the actions we take now are going to have the largest effect sometime in the future. And so my generation is not going to feel the principal effects of long-term climate change. It's young people, my kids and their kids will be dealing with the effects of whatever policy we choose to enact or choose not to enact today. And so we need to hear voices from young people.
Yeah, a good message. I think this is going to be where we wind up our formal Q&A, but don't get up yet, panelists, because we have some questions we've received from our remote audience. And if anyone here in the room has questions, please raise your hand to let me know. This would, I think, be a good time for us to thank the 3 panelists for their responses thus far to the formal questions. So I'd like to
Thank you.
External audience, in case you can't hear, there was good applause here in the room. Let me just go through some of these questions. Ethan Dittmanson asks, what reaction can we expect from the Biden administration on the recent IPCC report? And how might this impact the mission at LANL? So there's a lot to unpack in that, but who would like to speculate on the first part, Biden administration reaction?
Well, Well, Jane Lubchenco, who's a deputy in the Office of Science and Technology Policy in the White House, has just came out immediately. She is she's an ocean scientist, and she in very strongly in favor of the IPCC results and how important they are, and that we have to get down to business and do something about it. And I know because they interacted a lot with the Department of Energy, and we heard last night on television the Secretary Granholm talking about this as well. And so I think it's good news for Los Alamos, good news for the A-Team, that definitely the administration is on it. I mean, Biden has shown, I think, in many visible ways that he wants to demonstrate that the U.S. really cares about this and is going to do positive action on it. And as I mentioned earlier, Congress is, they're proposing all sorts of things. That's a more difficult, place to work in than the administration's voice. But I think it's going to mean a lot to other countries. I can't understate how important it is when the U.S., no matter for our our wins and our not wins, we've had some of both in the past several years. They and other countries may wonder if we've lost our course or not. That it makes a huge difference when somebody from the US, and I've experienced this, goes to these ministerials, to these meetings of lots of people around these important topics and speaks for the US constituency about how important it is to do positive action to mitigate what we see happening like in climate change. And we are still the global leader, and the other countries of the world really respect our voice. So
I'll combine here a couple of technical questions. Robert Green asked, what about the stability of the jet stream and how is that affected by climate change, at least as predicted by models? And another question from Ed Birnbaum was, did any of the models predict the recent floods in Germany?
I don't know much about the jet stream, but I'll say that the climate models are not really geared towards predicting individual events like this. And the reason is that, like Dave mentioned earlier, they're based on scenarios. So we make assumptions when we set up future simulations about what human actions will be that will lead to certain greenhouse gas emissions. And then we're looking with climate models at the responses to those emissions. But that by definition does not include, we can't be very specific about what people actually will do in the future. And we can't really include knowing when the next big volcanic eruption is going to happen and other factors that also play a role. So I would say that's definitely beyond the scope of climate models, predicting an individual flood like what happened in Germany. Do you want to add anything,
However,
Dave?
my understanding is that the German Weather Service did predict a very intense precipitation event, and that there was essentially a weather forecast. But there has been criticism of the warning system that was in place to potentially help people and spread the word that they were in trouble, which happens in the US as well. So there are multiple components to a forecast of an extreme event like that. Often the meteorologists sit back and say, well, we told you so, but it's not always easy to get the word out in timely fashion. And we all wish that we, instead of making a 1 or 2 day forecast of an extreme event, that we would like to extend the forecast lead time out to 4 or 5 days for something really extreme. Well, the stability of the jet stream.
Oh, okay.
There are multiple ways to answer that. So I'm not sure exactly what the question wanted to focus on. So instabilities in the jet stream generally are what make what we call baroclinic waves. That's where winter storms come from. They are instabilities in the jet stream. And that's what weather forecast models are generally really good at on a weather forecast timescale. So that's one potential answer to
But
that
maybe the question is, as you talked earlier about attribution and comparing with and without human intervention,
Yeah.
is the jet stream significantly different in the one versus the other?
So from a climate perspective, one of the effects of warming global climate is to reduce the temperature gradient between the tropics and the poles. And it's that temperature gradient that drives the jet stream. So there is some sense of making the jet stream somewhat less concentrated and therefore perhaps a bit more tendency to wobble around a bit. And there has been some educated speculation, it's not quite established yet, that by warming the poles, which happens dramatically as the result of global warming, you get polar intensification of warming, that you might make the jet stream wobble more and have more of these intense polar outbreaks, where counterintuitively by warming up the poles, you allow cold polar air to escape down and freeze Texas, like happened.
Yeah, well, I live much of the year in Austin, Texas, and we suffered through several days with no power and temperatures in the teens. And if we had been here, we also spend much of the year here in Los Alamos. If we had been here in Los Alamos in the winter, our house could be just fine with that, but not in Texas.
The no power was a different problem.
That's true.
That's not the meteorologist's fault.
I want to get through a couple more questions. Let me apologize in advance to people on the remote side whose questions I won't get to. Charles Keller asks, if the federal government doesn't do enough to reduce carbon emissions, are there things that communities or local governments can do that are meaningful? I'm seeing that you're that you think the answer might be no, but you're struggling with that.
A common criticism that we hear from policymakers is that why should we cause economic pain, jeopardize our economy, jeopardize our fuel supply by going out of our way to reduce emissions when so-and-so over there, whether that means India or China or even Texas, won't do the same. And so there's a great reluctance among many policymakers. Nobody wants to go first. And the only way to get around that is to come up with broader cooperative agreements. Now, having said that, a willingness, a demonstrated willingness and a commitment to reduce emissions, we would like to think would increase trust internationally to get the global cooperation that's going to be required to affect the global climate. And that's the basis of the Paris agreements that were negotiated late in the Obama administration that are the basis for current international carbon dioxide emissions policy.
So what I'm hearing is that the action by communities in a certain sense is mostly symbolic, but that symbolism is important because as more and more communities take those stands, it becomes easier to get national and international actions on this.
Well, that's true, but there are local actions. When we were in DC, my husband and I, our rented condo was on the Potomac, and we'd go out there in our kayaks, and it's absolutely littered with plastic bottles. littered with plastic bottles. I mean, and we all know that plastics in the ocean is just a huge, huge problem worldwide. I mean, there are tons and tons of that. So you can say a similar example about so much of the things we do. So I do think that there are community actions that can galvanize against some of the things that we do or take for granted that really can make a difference. And then there's the other, I mean, Chick Keller's question could be on many different levels, but I always think of Frances Arnold, the Nobel Prize winning chemist at Caltech, and what she's done to engineer biology to come up with all these amazing things that reduce the use of pesticides and stuff like that. You can engineer plants now that will take up more carbon in their roots, and people are working on that. So there are individual scientists who are making, extraordinary discoveries by thinking about nature differently that can really help with this. So yes, there are community actions, and yes, there are individuals. It's not all just about big government coming to our aid.
Thanks for that. Yes. Maybe the last question. I wish I had a great, huge question to go out on a bang, but I think this is an interesting one. It might be a softball for the two people who use models. Diane Matar or Matar, sorry, I don't know the pronunciation, asks, I'll summarize, if we spend money on developing models, for example, using AI or using machine learning and so on, is that the best return on investment for money that we could spend on climate? Or are there other areas, for example, the mitigation, where there are more efficient winds? I somehow bet I know the answer from the two people who do modeling, but.
I mean, I don't.
It's not just are you good, it's are you efficient?
Very. No, I think, Diane, models we use them right now to understand climate and to understand the impacts. But when we move towards evaluating mitigation and moving forward with that, I think we'll still be using models to some degree to help guide us. Unless, of course, your question implies that we move away from doing the basic research and move towards action on climate change instead. And so I think the CSIRO in Australia did that a couple of years ago. They decided that they had done enough climate research, basic research, and they were going to basically shift the whole institute to focus rather on adaptation and mitigation strategies and to really research approaches rather than research the basic science. And honestly, I started on this answer without really knowing what happened with that, but I think they had to pull back a little bit from it and say, well, there's still a lot of things that we need to go back to the table and do some science on and use models. So
okay, well, that's one vote for basic research. Do we have other votes for?
Hey, I'm really, and Diane Matar works for me. Okay, just so in full disclosure, she's just great. She really works on with funders, philanthropic funders on climate research. I just think the potential of AI to help out with all of this is huge. So I'll just say that.
Okay. Dave, do you want to have the last word on this final question?
Well, I think the answer has to be all of the above. So whenever we develop new ideas and have new modeling, then we quickly run up against limitations associated with the data that we need to help constrain the models and validate the models. And so it doesn't make sense to develop an awful lot of modeling expertise without having the data acquisition to go along with it in terms of research. And then when we try to apply the models, then we find all kinds of new applications, and there's the interaction with the policy community then drives its own innovation within the modeling community if all that interaction is happening the way it should. So a thriving research community depends on to a large extent, certainly in the climate business, interaction with policymakers and developing and maintaining data acquisition and analysis systems goes hand in hand with model development.
Thanks. Okay, I think with that, it's time to express thanks. Let me express my thanks to the 3 panel members for a very interesting discussion. And also let me now express the panel's thanks to the J. Robert Oppenheimer Memorial Committee for sponsorship of this event, and to the Pajarito Environmental Education Center for hosting this event. And with that, and maybe making our thanks to the panel audible or visible, I think we're done.
Thank you.